clicker. Here we go. All right, hi everybody. My name is Sivan Metzger. I'm the CEO of Parallel Machines, and I'm here to talk about where the cloud is going to be. The topic is really edge computing. So we've been talking about cloud for a good couple of years now, and it's really, of course, become the standard, the de facto standard. But things are changing. The paradigm of cloud is really starting to change, and I want to kind of walk you through, hopefully, a buzzword-free discussion about this. So what's actually changing? Increasingly, more and more things are being measured. So data-emitting devices are abundant everywhere. In the last 2 years, they're exploding, and they're about to, every forecast you can read is further exploding in the next 2 or 3 years. I've heard the SoftBank chairman and CEO say there's going to be trillion data-emitting devices by 2020. It's pretty crazy. What this leads to is essentially an unprecedented amount of data that is now being streamed that just wasn't streamed before. It's just new data that's been springing up in orders of magnitude. And what this led to, in turn, is up to recently, unimaginable scenarios are now real. And let's put the car aside. It's just a nice picture, but it's all around us. And I'm not talking about toasters and microwave ovens. I'm talking about enterprise type of real-time streaming scenarios. And I'll walk you through a few of them in a few minutes. But the underlying kind of common denominator between all those new use cases, essentially, is the real-time notion that simply wasn't possible before when we were doing only talking about cloud. Oh, here we go. Essentially, that previous slide was about unlocking the power of the edge, and the emergence of edge computing is really kind of the topic of what we're talking about today. So why is this, and what does it mean from our perspective as we like to look at it? The fact that you can do streaming machine learning at the edge is really the key to unlocking the power of that edge. In other words, enabling those real-time scenarios that we talked about. And the one important thing that we've learned is that it's not enough to open the power of the edge if these edges are not coordinated between them, if there's no logical connection and action that's being taken as pertains to that connectivity and the differences between the changes. In other words, in professional words, orchestrating those environments, this can cause more damage than benefit. So who are we? Parallel Machines. We're based out of Tel Aviv as well as Sunnyvale here in the Bay Area. We're strong believers in the machine learning transformation that the world is going into. My team is comprised of machine learning experts and distributed computing experts. And what we're doing is essentially meshing these two paradigms together to create solution for actual problems that are relevant today. I'm not talking about future stuff, talking about today. We have 10 PhDs on staff and 30 patents that are either issued or pending. Proud to be a Pitango, 83 North, Carmel company, as well as an ICAP company. So let's dive in a little bit. So the paradigm until now, which the cloud providers have led us to grow into, are that there's things out there, or devices, or databases, or whatever it may be, and they send information over to the cloud where it's stored or processed, and if needed, it gets sent back, which is great. And by the way, only about 5 or 6 years ago, it opened up a whole new world of possibilities that today we're all used to and accustomed to. But now is really kind of the wave, the next wave that's coming after. And why is that? Because when you send information to the cloud, inevitably, you're going to be creating compound inaccuracies in the data that's been sending until it's meshed, put together, synchronized, processed, and then sent back. It's inevitable, coupled by, of course, latency, which takes a lot more time than being able to process things much closer to the way they need to be. So what happens is essentially there are more and more devices in between whatever those things may be and the cloud, all kinds of devices. Just let me give you a really simple and basic example. So whatever your favorite cable company is in any country of the world, essentially you have a set-top box on your TV or right next to it, but every 10,000 subscribers, every neighborhood or small town or so would go into a gateway, right? That gateway is where you actually have your first compute power. Compute, think of it as horsepower to be able to conduct any kind of processing or algorithm or analytics. One of the biggest problems for these cable companies today is the fact that the quality of service is unpredictable, and very often it's poor, and the cable companies don't know when it's about to go down or what's actually the performance. By the time they do know, they ended up potentially losing a customer. This is kind of, if you look at this could be TV in a house, gateway, and then obviously the cloud. So the possibility to start running and leveraging the compute capabilities that are now in these gateways and closer to the actual think of it where the data is created and then consumed, okay? We're watching the TV, we're consuming this data, and the TV is kind of creating feedback to the cable company. Is it working, is it not, et cetera. But when you have 10,000 of those on every device, you want to be able to run that analysis. Essentially, that prediction is kind of the result of what an algorithm, is one of the results that an algorithm can create. You want to be able to do that at the edge itself, at that gateway. So the response back to headquarters or to the NOC of the cable company, whatever, will be very, very quick instead of sending all the 10,000 data all the time and sending it back in process. You just want to know, hey, is something going to go wrong? Because that's what they care about from a business standpoint, all right? So, and of course, coordinating the different gateways and understanding what's happening around them is key. So I want to kind of superimpose a solution to this kind of problem. Our solution comprises of 3 parts. One is the PM instance. Think of it as a software piece that gets deployed on those gateways, and I'll talk about some other scenarios in a minute. Capable of running, making decisions, predictions, or classifications at the actual edge. The next one is the manager, which deploys all the algorithms all around. But the third part is something we're focusing on quite a lot, is kind of machine learning upon machine learning. What does that mean? You want to be able to take and consolidate all those predictions from the different edges and bring them up to a place where on top of them making their decisions at the edge level, you want to actually learn from the different decisions that are taking place, the different conditions that are happening at the different edges. That's ECO, so edge cloud orchestration. Diving in, let's talk about another kind of scenario, a router scenario, enterprise router where Google is the customer and there's routers in their data center. We all expect very high response, of course, but machines and people who are using the Google Cloud or the Oracle Cloud or what have you require much more rapid response. So these instances, we deploy them on these routers that have to do now with the 5.9 SLAs and have to be up all the time. The second part is an edge manager, which deploys the algorithms to the different routers. And as I mentioned, the brain that sits on top of everything is synthesizing all that learning, pulling it together and defining policies. Let's dive into this router example. So the pain, and this is, I'm trying to bring all these words into an actual use case. The pain is that the routers or MRIs or gas turbines, in other cases that we're working on, don't always work as expected. And the owner of those, the owner of the service, whoever committed to the service, needs to be able to predict when and if and what kind of problem is actually about to happen, because you don't get many chances to fix your not 5.9 SLAs. So in the case of the router, it turns out, and similarly in the turbines, there's hundreds, if not thousands, of channels of what's called telemetry, of control of that router or that gas turbine that run all the time. To process these, what we do is we conduct what's called multivariate anomaly detection, and that fancy word leads to the fact that you can actually find a needle in a haystack. How do you find, in advance, from thousands of streaming channels, on a router, on a gas turbine, on an MRI, how do you find that needle in the haystack? This is what we do, multivariate anomaly detection, predict the issues in advance, push them up to conduct any corrective action, and from there on it goes. So I hope I gave you some color to the world of edge compute and to the use cases that these are feasible to be today. And come grab me to learn any more. Thank you very much.